All right, boys and girls, this is going to be a really quick and easy way to explain outcomes and permutations. Obviously isn't everything, but this will be a quick review of some things that you already learned. Um, Outcomes, remember, the number of total possibilities, things that could actually happen. And just for instance, if you flip a coin, there's two outcomes. There's heads and there's tails. So in this problem, just want you to read the top. A penny and a dime are tossed at the same time. What is the probability of tails on the penny and heads on the dime? So if you're going to do probability, you need to know the total number of outcomes. So to know the total number of outcomes, we can make a tree diagram where we say the penny could either be heads or tails. And no matter if even if the penny was heads, the dime could be heads too, or you could have heads on the penny and tails on the dime. So putting them together gives you one of the outcomes. Getting a heads on both the penny and dime is an outcome. Getting a heads on the penny and a tails on the dime is an outcome. And here are the other outcomes that could happen. So you could see, if you count them, 1, 2, 3, and 4. There's 4 outcomes. Well, you could have got that same answer if you used the fundamental counting principle. That means you just take, when you go to flip the first coin, how many things could happen in that one? And there's 2. There's heads and there's tail. And in the other one, there's also 2, because there's a heads and there's a tail. So if you multiply those together, you get 2 times 2, which is 4. That tells you there's 4 total things. And if you had to do the probability, you would need to actually list them out, because now you can see that a tails on the penny and heads on the dime happens once. Tails on the penny, heads on the dime right here. But there are 4 total outcomes. So the probability for that to happen is 1 out of 4. Same thing happens here. Kyle wants to buy a portable TV. One model has a 13-inch screen, a 19-inch screen. Then you could get 3 cabinet colors. Well, if you just wanted to know the total number of outcomes, instead of making a tree diagram, which you can see right here, you could take that there are 2 choices for screen size, 19 and 13. So that's 2. Then you get 3 choices for colors. Well, if you multiply 2 times 3, we would know right from the beginning that there is a total of 6 outcomes. And then you can use those outcomes if you wanted to list them in a tree diagram in order to find out probability of certain things. Here's another one. So if I told you that there were 4 desserts and 7 coffees, and you want to know how many outcomes there could be. So, for example, I could have apple pie and I could have a decaf coffee. That would be one outcome. But by having 4 desserts and 7 coffees, I know 4 times 7, you would get 28 different possibilities of those coffees and those desserts. So another one would be if you flip 2 coins and toss 1 die. So the first coin would have 2, the second coin would have 2, and the die, which is a dice, it's 1 dice. It's a six sides to that. So you'd have 2 times 2 times 6, which would be 12. And that's how you use the fundamental counting principle to find the number of outcomes. Well, you could also use fundamental counting. Well, so here's an example. And what I want you to do after I read this, I want you to pause the video, and then I want you to do it, and then I'm going to show you the answer. How many different outcomes are there if I roll 2 dice and flip 1 coin up? You know what? Interestingly enough, we just did this one. So after the first dice, there's 2 choices. On the second dice, 2 dice and flip a coin. So when you roll the first dice, there's 6 outcomes that could happen. The second dice, there's 6 outcomes. And when you flip a coin, there's 2. So 6 times 6 times 2 will get you 72 total outcomes. And right here, if you wanted to name one of the outcomes would be something like you get a 1 on one of the die, you get a 2 on the other die, and you get a heads on the coin. This would be an example of one of the outcomes. But remember, there's actually 72 of them. You could also solve problems like this using that kind of thinking. This is a problem that I got when I was in school. The license plate's in Maryland. There is a number, then there's followed by 2 letters, dash, then there's another letter, and then there's 2 numbers. And obviously there are vanity plates, but this is what most of the license plates in Maryland look like. Well, if you ask how many different plates there could be, we just have to use the fundamental counting principle. In the first option, there's numbers. Now, it's a single-digit number, so you could have a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. That's 10 different options. In the second choice, it's a letter. There's 26 letters in the alphabet. In the third one, it's a letter. There's still, you could have double letters. You could have AA or XX or VV. So there's 26 different options. Then after the dash, there's more letters. Again, 26 different letters. And the last two are numbers. And since they could repeat, we know there's 10 options, 0 through 9, which are 10 different numbers. And then there's finally 10 numbers. So now that you have all the choices, if you multiply this together, this will equal, and I'm not going to do this for you, but if you just get that really large number, that's how many outcomes there are. And of course it's going to be big. There's a lot of people in Maryland, so you need to have different, each person needs to have a different license plate. All right? How many different locker combinations are there? And you can't have the same number twice. So you could have a combination of 2, 10, 2, but it couldn't be 2, 2, 2 or 2, 2, 8, because then you have the same number twice. But you could have the same number, it just can't be right next to each other. We also call things like this permutations because you're arranging all the numbers in a certain order. Whenever you're putting something in order, we like to think of these as either a combination or a permutation. Now, even though this has the word combination in it, in real life, it's because the order of the number is important. 2, 10, 2 is a different combination than 10, 2, 2. Because even though you're using the same numbers, this is completely different. You know, this would not open this locker. So when the order is important, we think of this as a permutation. Well, permutations are done just by using the fundamental counting principle. So if you think about it, there are 30 numbers on your locker. It goes from 0 to 29. So that would be 30 different choices you have for the first number in your combination. So then you have a second number in your combination. Well, we can't, once we use one of the numbers, we can't use it again. So in this case, now there's actually 29 different numbers we can use. Now in the third option, well, let's say the first number, the number was the 4. Well, you couldn't use it in this one, the second number. But now the third one, you could use a 4. But whatever number you used on this one, you can't use again. So there's not really, you don't have 30 choices, you still have 29 choices. 30 times 29 times 28. I'm sorry, 30 times 29 times 29 is equal to, it's a really large number, 25,230. So there are this many different locker combinations that, you know, if you wanted to, you know, get into someone's locker, you would have to, you know, you might get lucky and try, you know, get the one right, but there's this many numbers that you'd have to go through in order to ensure that you would be able to get into that locker. Here's another way that we have a permutation. 8 pieces of art. Again, we're ordering something. And whenever you're ordering something and the order is important in them, we think of this. We use the fundamental counting principle, but it's a permutation. There's 8 pieces of artwork, but you want to put 3 of them on a wall. And the way that you put them up is important because it'll look different. If you have artwork A, B, and then C, that'll look different on the wall than C, B, and then A, because the way that the colors are going to intertwine, anyone that knows art is going to say that's going to look a little different. So the order is important. So we know that we have 3 choices to make. Now, when I go to pick amongst those 8 artwork, I have 8 choices. But now I put one on the wall. So for the second one, I'm going to have 7 choices. And for the third one, I'm now going to have 6 choices. So the fundamental counting principle to tell us how many total different ways that there are, I'm just going to multiply those together. And if you have 8 pieces of artwork, 8 times 7 times 6, there's actually 336 different ways that you can put that artwork on your wall.